Hi, my name is Kunda Chaikatisha, and I'm a cloud solution architect for data and AI at Microsoft. And today I'll be discussing the topic MLOps with Microsoft Azure AI Platform. And if you want to get in touch with me or to have a chat with me, you can do that on LinkedIn. My LinkedIn profile is Kunda Chaikatisha. Pop me a message there and we can start talking. So let's get straight to it. Now, the very first question that we may ask is what exactly is MLOps? And granted, there are many interpretations out there and takes on the subject, but our take on it is that it's about bringing DevOps principles to the machine learning and AI workflow. And that helps organizations and teams to be able to collaborate better because they are all working around the same code base in source control and a repository of choice. It also enables organizations to automate aspects of that ML and AI lifecycle with continuous integration, for example, where whenever somebody checks in new code into the repository, it kicks off a continuous integration pipeline that builds the code, tests it, and produces artifacts for deployment, and then a continuous delivery pipeline that takes those artifacts, tests them, and then puts them in a production environment for consumption by applications. And many of those components of that lifecycle can be automated, but you can also include manual checks at stages of that workflow to implement your quality assurance that you require in your use case. It also helps the process to be more reproducible and auditable because you are checking in and versioning code, you are versioning your models, you are versioning your data sets, software environments, you're logging in metrics from your models during experimentation, and you're getting the telemetry from the models in deployment. And all this metadata helps you to go back into history. You're able to see what you did, retrain a model using the same configurations that you use and versions of data set that you used in the training process. And that helps the entire process to be more auditable and reproducible. So there are indeed real benefits in adapting DevOps principles and applying them to ML to enhance the ML lifecycle. And we're going to look through how the Microsoft Azure AI platform helps you with the technology components specifically to achieve MLOps in your operations. So how does the process look like at a high level? You see there in the slide, there's a number of stages in that life cycle. First, you train the model, and then you package the model with the software dependencies that are required for the model to run in production. And then you deploy the model in a QA environment for validation, and then you deploy it into production. And then in production, you can get telemetry from the model that gives you a feedback loop for analysis or for triggering model retraining, or you can retrain the model based on a schedule that you select in your environment. Now let's see how you can achieve this using the Azure AI platform. Right, so how do we get there? How do we begin to build these MLOps functionality and components in our project? So we might be starting from a point where there is no MLOps. We have data scientists in the organization getting data from the data engineers. Data engineers are running their own data pipelines that create data assets for the organization to be able to solve business problems. And so the data scientist has access to that data. He does some featureizations, selects an algorithm, trains it, and then finds a useful model through evaluation. But then what next? We want to take it a step further. Let's see what the next step is. Now we want to make the training process reproducible and automated. And Azure Machine Learning helps you to do that. Within Azure Machine Learning, you're able to set up machine learning pipelines that automate the process from data ingestion, preparation, selecting of a model, and then finding a useful model for you to register in the model registry. And at the same time, you're also capturing telemetry and metadata about your process, your data sets, your software environments and packages that you're using, and log them within Azure Machine Learning. And then once you have built that machine learning pipeline in Azure ML, you can then publish it with the click of a button into the cloud. And then after that, you have a REST API endpoint that you can use to invoke the pipeline to run on demand or on schedule as required by your use case. And once you do that, then you have an automated training pipeline that you can use in your use case. So once you have an automated machine learning training pipeline, what's next? How do you create a deployment process with automated tests, stage releases, and deployments? And that's where Azure DevOps comes in. It's another service on Azure, and you can integrate Azure Machine Learning with Azure DevOps so that once you have a new model registered in the machine learning workspace, it automatically triggers a release pipeline in Azure DevOps to begin to go through the process of packaging the model, certifying it, and then releasing the model into the production environment. And once you set that release pipeline up, then you have a mechanism to automate stages of that release process. So the next thing you want to do is want to stitch all these components together. So we see there in the slide we have the Azure Machine Learning pipeline, which automates the machine learning process and produces a new model when it runs. It registers that model in the model registry in Azure Machine Learning, and then once that a new model is registered, it kickstarts a release pipeline in Azure DevOps, which goes through the process to package and certify the model and then release it into the production environment. And then once it's in production, we have services on Azure that help you to collect telemetry from the application or from the model in production. And then there's a feedback loop there where you can take this telemetry, put it in a data lake, do additional analytics with data pipelines on Azure Synapse Analytics, for example, to create a fresh data set that will be used in training a new model. And in fact, you can also integrate Azure Synapse Analytics with Azure Machine Learning so that once you have a new data set created, triggered, for example, by things like data drift or model drift, you have a new data set created through an ETL process, and that pipeline triggers Azure Machine Learning to train a new model based on a fresh data set. So we're going to look at a demo that steps through this life cycle. It'll be a story of three pipelines, as you can see. One pipeline in Azure Machine Learning to train the model, another pipeline in Azure DevOps to release the models, and a third pipeline in Azure Synapse Analytics to do your ETLs and prepare fresh data sets that will be used by Azure Machine Learning to train the model. So let's see how this works in a demo. Okay, so the first thing that we want to do is we want to build the machine learning pipeline in Azure Machine Learning. And this will take us through the steps of and automating the steps of data ingestion, preparing the data, training the model, and then registering the model in the workspace. I'm going to use this Python notebook, but you can also use the designer, which is more of a drag and drop low-code user interface for building pipelines. But for this demo, I'll just step through this notebook and use this to build our pipeline. So the first part of the notebook, just bring in the pipeline packages that I need to be able to build those pipelines in this using this notebook. I bring in the configurations for my workspace, uh, connect to my compute cluster that I've already provisioned for this workspace, and you can do that easily by going to the compute tab here. There's a once you click that, you see there's a very easy step-by-step process for you to provision compute that you need to run your pipelines and your inferencing. But crucially, there's this step here where I need to create a pipeline parameter. And this is really important because it enables us to have an external service, a service external to Azure Machine Learning to be able to pass parameters dynamically at invocation. And in this case, we'll be passing a training path parameter for the data set. Whenever data set is created by another service that we'll look at in Azure Synapse, that data set will be the path to that data set will be passed at invocation, and then the Azure Machine Learning pipeline will be able to use the new data set once it's triggered to run with it. So the next few steps here will define the actual steps that the pipeline will run through, with the preparation step, the training step, and the registration step. And you see here that it's referencing these Python files there, Python scripts that implement the actual logic that will run through the process of training, preparing, and registering the pipeline. And then The next part is I just validate the pipeline and then run this to build the pipeline and then to publish it in my workspace. So let's see how it will run, and then we'll publish it, and then we'll have an endpoint that we'll use um, to refer to that workspace. So once you start running that notebook to build the pipeline, you can go to your experiments to see what pipelines are running, and you can see this pipeline is being built here. Some of the steps have already completed with the preparation, training, and now it's starting the registration step. If I go into my training step, I'll see the model metrics that it was able to log there, and you can, with more configurations, you can get really sophisticated logs and telemetry from the training process put together for you to be able to audit and to check later. You can also see the run status in the notebook as well as it's running, and now it's completed, but you can see the status here with the progression of the pipeline build process. And then, once you complete the run, you can then go ahead and publish the pipeline into the workspace, and that gives you a REST API endpoint for you to refer to or to make API calls at invocation. And to see your endpoints, you simply go to pipelines, go to pipeline endpoints, and then you're able to see the endpoints that you've published in your workspace. In which case my endpoint is the AML training pipeline. And if you want to see the model that is trained, you can go into the models tab. There you see all the models that I have registered in my model registry on my workspace. So I have a model that is registered. I have a pipeline that is published that with a REST API endpoint that I can make API calls to and automate the process of training a new model on demand or on schedule or as I see fit in my use case. Okay, so far we've created a machine learning pipeline in Azure Machine Learning, and that pipeline automates the process of training the model and then registering the model in the workspace. But what we want to do now is to build a deployment release pipeline, which will take those model artifacts, the actual model in the machine learning workspace, and then take it through the stage release until it's sitting in a production environment. To do that, we'll use Azure DevOps, and I have my Azure DevOps environment open here with my project open. The first thing that you want to do is you want to connect to connect these two services, to connect Azure Machine Learning to Azure DevOps, because these are two separate services. So to do that, you go to Service Connections, and it's very easy. I already have some service connections there already created. But to create a new one, just go to New Service Creation, Service Connection, go to Resource Manager, click Next, Service Principal, click Next, choose choose Machine Learning Workspace, and then it will give you the subscriptions under your account, and you choose the resource group, the workspace, give that connection a name, and then you save, and then you would have a new service connection that is available for you to use. I already have a number of them that I've created, so I'll not create a new one. So the next thing that I'll do now is that I'll go to my release pipelines and go to releases. And when I go there, then I can, as you can see, there's already a number of releases that I've made there. But what I want to do is I want to create a new release pipeline. And then this will take us through the step on how to create releases that will bring in the model artifacts that we'll use in production. So the first thing I'm going to do is I'm going to add an artifact. And the first artifact that I'll add is the repo itself. If I make any changes to the repo, I want that to kickstart a new build to happen and a new release to take place. So I select the repo. This is my project. This is the name of my repo. I go into I'll use the main branch and use the latest version of the main branch, and then I click add. The next thing I want to add is I want to add another artifact, and that's the artifact for the machine learning model itself that is registered in my Azure Machine Learning Workspace. So I'll choose the Azure ML option there, and then the service endpoint is the one that I've just created in the previous section when I was creating the connection with Azure Machine Learning, and that's the name that I've given that service connection. And you notice something here that when I click on the model names, it can automatically see all the models that I've registered in my model registry in Azure Machine Learning in the workspace that we just built. And in which case, the model that I'm looking for is the workshop model. I'll click that and I'll use the specification here that this will be the latest model version that I have. I'll click add and then I'll go to the next step. So the next thing that I want to do is I want to configure this release pipeline so that whenever there is a new model that has been registered in the Azure Machine Learning Workspace, that it automatically triggers this release pipeline to begin to take that model and push it through the deployment stages. And to do that, I need to click this button here, and that button there says continuous deployment trigger. Enable that, and that will give us that functionality. And once we do that, we can begin to add the deployment stages. Right. The next thing that I want to do is I want to add the deployment stages, and the first stage I'll add is the QA stage or the quality assurance stage. I'll just name that QA ACI for Azure Container Instance. Save that, and then begin to define my job configurations. So I'll put the specification there for my agent job as Ubuntu 16.04 for the OS, and then I can start beginning to add tasks to that. And the task that I want to use is a Azure Machine Learning deployment template, which I'll add to my job. I'll keep the name as is. I'll choose the workspace where I have a connection to, use the model artifact, and then um, get my inference configuration. And basically, your inference configuration contains the software dependencies that your container instance will need for it to be able to deploy. So I'll put that there, and then I go to container instance. I'll keep it as is. Deployment name, let's give it a name, and then the deployment configuration file basically is the specifies the amount of CPU, the size of the CPU, and memory that will be provisioned on the ACI instance that you're going to deploy. So I'm going to click that, and then everything looks good, and then I'll save that, and that gives me my QA stage. Okay, the next stage I want to make is a production stage, so to deploy into prod. So I'll just clone that and then go into the new stage or the clone stage and begin, and maybe just change the name there to I'll be deploying into Azure Kubernetes service. So I'll say prod AKS and then begin to modify the agent job configuration. I'll keep that as is, but I need to make some changes um, in the compute target that I'm going to use, the deployment target. This time around, I'll put Kubernetes service. I going to select the Kubernetes cluster that I already have in my subscription. Give it a different name. Choose the AKS configuration file, and once that is selected, and then you're done, and then you have your QA pipeline that is ready for you to use. So to test this release and to run it, you just say create release, and then that's the pipeline. This time around, we'll trigger it manually, but since we've already connected it and we'll test it a little bit later, we've connected it to Azure Machine Learning and it will begin to run. Um, in which case, I already have releases that have run successfully, and once they have run, you'll be able to see um, the run details through deployment to ACI, Azure Container Instance, and then a successful deployment to Azure Kubernetes Service. Right. So far we have created two pipelines, one in the Azure Machine Learning Workspace to automate the training process. We've also created a pipeline in Azure DevOps to automate the release or the process that takes the trained model into a production environment. So the next thing that we're going to do is we're going to create a data engineering pipeline that will create fresh data sets that will be used by the machine learning pipeline to train new models on demand or on schedule. So let's see how we can do that using Azure Synapse Analytics. So I'm in my Synapse Analytics workspace here, and the first thing that I want to do is to connect to my Azure machine learning workspace so that these two services can speak to each other. And the way to do that, you go to the Manage tab there, and then you look at linked services, and basically these are services, other services in Azure that you can link to Synapse, the Synapse workspace, so that you can begin to integrate these services. So in fact, I already have that linked service to Azure ML service. And this Azure ML service linked service is basically a link to the workspace where we built the machine learning pipeline. So, but to do that, you just click New, search machine learning, and then these options come up. You choose machine learning, click continue, and then you go through the process. Very intuitive process there. Just give it a name, um, keep most of the defaults there, and then choose your subscription, and then you choose your workspace name. I've already done that, and basically it's quite a simple process for you to get that going. Okay, so we've created the link service to Azure Machine Learning. The next thing that we want to do is to create the data engineering pipeline. And to do that, we'll go to the Develop tab, and then you click the plus button there, and then you choose data flow. And basically, data flow will be the logic that you use to ingest and transform your data, and then you can store that data in your repository of choice. And in this case, I'll be using the data lake that I've provisioned with this workspace. So when you click that, I already have a data flow that I've created here, and what it's doing is it's getting data from these two data sources in my data lake. And in fact, one of these data sources is here. You can see the CSV files there with the timestamp on when they were created as part of the naming convention for the files. And then it's doing some join on those data sets, and all these things are, it's a graphical interface. You bring in these blocks by just adding a plus button and then configuring it. So it's a really intuitive and easy to use low code approach to building the logic that you're going to use in transforming your data, and then removing some duplicate columns there, and then saving that into another data set, and this will be the data set that will be used by the training pipeline in Azure Machine Learning to train a fresh model. Okay, so for me to be able to consume this data flow, I need to go to the Integrate tab and then create an integration pipeline. So the first thing I do there, I'll click plus, and then click pipeline, and then begin to bring in the blocks that I need to reference that data flow, set the parameters and the settings, and then be able to set the trigger as well. So I've already done that here, and this is the block, the integration pipeline that I've created. You see there in the settings, it's referencing the data flow that we just looked at in a few minutes ago. And then there are also parameters, but crucial on the parameters here, you're able to set dynamic expressions that, for example, in this case, I'm using the dynamic expression here to create a string object that will be the name of the data set that I'll create after the pipeline runs, and then save this data set with this name, create data plus the timestamp, which is now the current date, and then save that to the data lake. And that is a very flexible way that you can set the variety of parameters that you need for your pipelines to run in a dynamic fashion. Right. So the next thing that we want to do is we want to configure this pipeline in such a way that once the data flow step runs it and creates a fresh data set, it will pass the path parameter of that data set to the Azure Machine Learning pipeline and trigger it to begin to run and consume that fresh data set. So to do that, you go to the activities column and then bring in this machine learning block there, and then go through the process of putting the settings and the parameters that you need um, to to create that connection between the data flow step and the machine learning step. So what I've done is that I've already created this block here with the settings. So once you do that, you can bring in you can choose the workspace, and this is a linked service to that workspace where we have the AML pipeline published. This is the pipeline name. Um, and in fact, once you do that, once you create that connection, you're able to see all the pipelines that are published in your workspace. So you have visibility from Synapse of those workspace components that you publish. But the crucial step here is to bring in the parameters that you defined in the pipelines in Azure Machine Learning. And once you import that, it's able to see the pipeline parameter that we created there, which is the training data path. And we can use a dynamic expression here to set the path name dynamically with a timestamp and the folders where this is going to be saved, and this is passed to the Azure Machine Learning workspace for the pipeline to consume and begin to run. And the next thing I want to do now is to set a trigger for this pipeline. To do that, you go to the trigger tab. You can trigger it. You can say trigger now for it to run on demand, or you can also set scheduled triggers here by going to the add new trigger. You give a trigger name, and then you can choose the mechanism that you want to run the trigger on, whether it's on schedule, tumbling window, storage events, or custom events, where you have events happening in services on Azure, and then these events are propagated to Synapse Analytics for it to be able to run triggers on event-driven workflows. So for our purposes, we'll just run it on demand so that we can see how it runs. So I'll just say trigger now, and then go ahead and start the run to begin. So in the end, we see this picture here where we have the Azure Synapse Analytics pipeline that prepares data set, triggers the Azure Machine Learning pipeline. And here is the Azure Machine Learning pipeline that has been triggered and run successfully in Azure Machine Learning. And then after a model is registered, automatically kickstarts the release pipeline with the QA and prod. And you notice here that it's waiting for my approval because I set it up with a manual trigger to approve to deploy to prod. So I'll just click approve and then click that, and then it will begin the process of deploying that to prod. And there's the end of our demo, and hope you found it informative. Thanks again for joining me. I've put some links here that you can refer to if you want to dig a little bit deeper. And as I already mentioned, you can get in touch with me on LinkedIn as well. Enjoy the rest of the conference.